So, hi, my name is Aryan and I'm doing my assignment 3 of my data science, applied data science, deep learning. So, this is part A. So, first of all, we are just importing the necessary libraries for the Python so that we can go through just do it more easily. So, did it here. And then now we're just using this variable, putting the link which we are going to use. And then, yeah, so this is the link and it's over here, and then printing that link. So like how computer sees is like this with these numbers. So you can see these numbers like different numbers. Like we can't understand what is going on, but like how this is how computer understands. So right now what we are going to do is we are just converting it so that it's easier for us to do the convolution part, the 2D conversion. So we are using a num array, so that we converted the image in array, and it will be easier for us to read, easy for like computer to read it. So let's see how like image looks. So this is like from this I am sure. So this is how image is. So this is Lamborghini Aventador in orange. It looks nice. I wish I could have it. Enough money. I don't have enough money, so yeah, leave it. That's not necessary topic. So right now it's just what we are doing is like we are printing the shape of the image. The shape of the image is like 140, 359 and 3. So this is, you can see, is goes up to this. So this is shape, and now it's comparing. So these two are not similar, as you can see, is false, and then this again it's not similar. So comparing the values, the channels 0 and 1 are not same, 1 and 2 are not same, so every channel is different. So now we are just using the channel 0 to see how the image looks. So when we do that, so when using channel 0, the image looks like this, like it's more like fluorescent color, like more like highlighted green color. And when you use the visualize the see the values inside the array, and we just like this, so it's like maxed out to 255. So now we know doing the convolution with 2D kernels. So now we just like starting the good part, so like how this works. So first of all we just need to like like where we start like to study, but we need a padding so that it doesn't cross or go over the actual image. Then it would be not like, it should be like up to the image or like have some padding to like safeguard the output, the image which you're producing. It's going to produce over the certain image, over the image. So this padded array, and this you saved it in here, and then if we create a kernel. So kernel is like with this 001 given code. So this is how it is right now, and then the output is like in the shape. So create an output array filled with zeros. So it's like zeros with same shape of, like if it's the same, it's filled with zero. So we did that, and then now we are printing. So this, the original array is like 140 and 59, and the padded will be 140 to 157. Just to safeguard it, like to increase length so that it doesn't go overboard. And then now applying to the kernel, apply kernel to the array values, and doing this, the for loops to make it apply on it, just to create a new one, like to produce the different image. So now the image, which is like output image, comes like this, using grade, so it's like black and white. So this is how it looks now what we are doing standard convolution. So like, so what is this, like this, like if value is less than 0 then return 0, otherwise if values is less than like 255 then return value, otherwise return 255. It's like in between, right? This is what it is. And this is again like kind of thing like which is given to us, and then doing the whole thing function to apply convol 2D kernel onto an images. It's like doing it, like producing another image basically in this, the base image. Just keep doing until this keeps going up the that, and in that sense. So this is given to us, and this is like whole like producing, like making it convert 2D and an image. And now what we are doing is like line detection. So this is like what is whatever, it's like it is like horizontal kernel. So these like they're certain kernels, like they're vertical, horizontal, and 45 and 135 degrees, as you can see. So here, like these are the different like array sizes of them. So like if this horizontal is like minus 1 1, and then this is a vertical one, minus 1 2 minus 1, as we are using the horizontal one, which is minus 1 minus 1. You see, so this is it. And then producing. So what is it like? It will create more horizontal line. As you can see, the more horizontal lines are more like darker. You can see them, it's like more whiter in here when you produce this applying Canon on it. So like it's more focus on that, the whiter side horizontal lines in the image. And when we do for the 45 degrees, you can see it's given, like you can see it's like here, you can search for it, it's like basically same for it, so same for everyone. So this is what array should look like. So yeah, so this is how it's looking. And then it's like it's at 45-degree angles, lines are more highlighted than regular horizontal lines. As you can see we are seeing the horizontal lines more darker. Now we are not seeing that. And same goes when it's for 135. So it changes like what line it has to pick for the image, and like how it's gonna process that image, what its like priorities are when we use certain kernel arrays, and then do it and then applying the kernel on the image. So this is like how our output comes to us when we focus on certain things. So now we have to do like create an edge detection. So now we are detecting edge on the image. So this is the one given us to us, and this is the code I wrote. So like it's similar, it's just like focusing on edge. Before it was focusing on the lines, and it's now focusing on the edge. You can see like it's putting on more edges images. And when like do different arrays, still this is not same. So it changes, like, so it will focus according to this. So like when you specify this, it's gonna go according to that, and like creates our image like that. Like this is the best one. You can see like this has almost all of the lines and in it, and like sees like better version of the above images. So now we are importing the libraries and necessary package. So the change I did, like in the previous code, the code which I given to us like doesn't work with Keras now only. So we updated it. So you have to write TensorFlow before it to work it, make it work. So yeah, importing those like again to use it in the future. So now we are training our data set as usual. It's same, like first train images, train labels, and then test images and stable, and this is the classifier. Like it's loading the data. So yeah, we did that, and this is how we are coding the two categorical method and doing this. This is the plot type, the type we are using, and normalizing it from 0 to 1 range with like 2 to 5. So like divided it. Makes sense. Like this is like all basic stuff, and now this is the interesting part. Like now we are creating model sequence. So this is the first layer. As you can see, the Convo 2D layer, and this is as 32 3x3 and padding same, and activation ReLU. We're using ReLU activation. Do it, and then this is the input shape which we are looking for, and then this is the max pooling platter, and then this is the different layers. So there are 5 different layers. You see 1 2 3 4 5 different layers going through the model, and then we compile that model, and then the summary. So summary is this is summary which came out. And now just like callback. So this is custom callback call. So like how it will like improvise itself. That's that. And then this is custom callback. CC is equal to custom callback. So it's given like particular name to it. Okay, so now we need to train our data. So it will go through the whole process now, how many approaches we want. So it's like we said it's 50 and the batch size is 256. Then train images, and then like now it's like making computer and machine to understand what we want us to, like how much accuracy it gives when we have input this much layers. So it's gonna learn, understand what is images, and okay, so what is the accuracy is when we provide this much in layers. So it's like around 65%, 64% stays around an average 64. As you can see, the average is 64. 64 is an average. Here, the average accuracy we reached while training. The validation accuracy is around 64. So this is it, and then this is the how plot looks, and it's just different. It's like started the same, and then the validation accuracy and training accuracy is different because training, like, but it's not available to validate that much. But when we do it, like, just if we just keep doing it, and then it increases the probability, if we increase the layers, So you can see like I increase the layer, the immediately the validation changes. So now validation is like I've added an extra convolution layer, so added extra max pooling also. So go through the similar one, but like it's now extra like extra layer to learn. So the values will increase, like it has to, because like now it has more data to understand what is going on and like how image is gonna be, like the validation will be more correct, and then the plot, like, the image will come like more similar to this, but I messed up, and then now I don't want to, like it takes too much time and too much machine power to load that, but like it will be like much more like closer to this one. So did that, and then now what is like dropout layer. So what, like how dropout layer, you should not use it before the last layer, and like most probably use the in the second last or like third last. Try to use it, because like if you use last, like it doesn't work that way. So what it does drop out the half of the layer above, so it will drop out, and then it will use the unseen data and then activate through that. That's what it is. So like it gives like machine to learn like more accurately and more like able to do solve more like hard codes, you can say, like more better way. So that's what dropout is, and then now we are doing it 50% of it. That's what I understand from watching this video, which is like amazing to understand like how it works. So that's cool. So like it gives like new feel to the data set. You can see what dropout does and helps us to understand. So now as you can see average is like around almost 72 or 73% if we calculate all of it. It's still loading. That's why I didn't do it, because it's take too much time. So it's still doing it, and yeah, so 75%, the 30 is like I just go more, because like number of approaches is very high, so it takes time to train all of that images, like all of the data set. So we did that, and then this will, the graph will start coming closer what it actually should be. Like it depends about how much data set we are giving. So dropout also benefits overfitting also, because yeah, it loses the data set, and then it kind of like helps itself to not do overfitting that much, and then it provide better outcomes. So, and like now I did way more data set to learn, and it will probably would be the better option to go, because now the accuracy will be much higher, because I have more data set to work with and all of that, which like kind of helps whole thing. So again, like I did load it, but like then I just messed up and I just keep doing dumb stuff. So yeah, this is whole of it, like when you just start inputting extra data, and then how the compiler and the fit works, this also changes. So it's all one data, like whatever we're doing with data, how many layers in the data to understand the machine, like how many layers we are putting. It's all about that, how many layers are there. More the layers, like it is like balancing, try to balance with enough layers and not going over fitting, and then sometimes works, sometimes doesn't, but yeah. So it sometimes doesn't matter if you put like too many layers, so like doesn't gonna do any better, but like try to find a better way, like better way around to do that. So yeah, that's my assignment. Thank you for watching. Peace.